Welcome back to quadratic functions. For today, we're going to discuss the standard form of a quadratic function. So, having the standard form of a quadratic function is tantamount to saying that we want to get the vertex of a given quadratic function. Therefore, our objective here is to solve for the vertex of f of x equals ax squared plus bx plus c. This is our general form, okay? And we want to express this in standard or vertex form. Okay, so here let's say we are given f of x equals ax squared plus bx plus c. Our object here will be for us to write that into the form y equals a times x minus a squared k, where our vertex is what? At hk. Okay? So, notice that we want to have a perfect square trinomial here, so we can write it as a square of a binomial. Meaning, from this one here, I'm going to have this expression here transform into a perfect square trinomial. Now, I will factor out a. Although a is not common to both of these, look at your common monomial factoring. If this is common to both of them, then I will just say ax divided by a is x, and then ay divided by a is y. Suppose I will have here ax plus by, and I want to factor out a. It's the same process. You divide this by this, so you will get this. What if you divide this by this? Then you will get what? B over a y. Okay? So, if you want to check whether your division is right, you can multiply. A times x is ax, a times y is ay. Here, a times x is ax, a times b over a y, this one cancels, and what you have is b to the y. Exactly, that's what we're going to do here. We are going to factor out a, and I will get ax squared divided by a will give me x squared. And here, bx over a will give me b over a x. Now, it is this expression that I want to have a third term, so it becomes a perfect square trinomial. And remember how we did that? The formula for the third term is actually 1/2 the coefficient of x, and then you square this. So, this one is 1/2 times b over a squared will give me b squared over 4a squared. Which means this is the term that will make this one a perfect square trinomial. So I'm going to add b squared over 4a squared. Now, I added this, so I should subtract it also. So it will not change the value of this original expression. And then we have a plus c there. Okay? Now, the reason why I wanted to add this is for me to be able to write this as a square of a binomial. But I needed to immediately subtract that so that I still have the same original form. Okay? So I can have that one now as I will distribute a to these first three terms. I can have x squared plus b over ax plus b squared over 4a squared. And then, I will distribute a to this one here. I get a times b squared over 4a squared plus c. C is out. A does not affect c. Okay? So, writing this now, I will have now f of x equals a, and then this is now a perfect square trinomial. I can write it as x plus b over 2a. And here, I can cancel a and a squared here, so I will get here what? B squared over 4a plus c. Let's express this in simpler form. So we get ax plus b over 2a squared plus, adding these two, I will get here 4a. 4a divided by 1 will give me, I'll have that addition first, 4ac, and this one will give me minus b squared. Okay? So, here, I can now write this in the form f of x equals a x minus h squared plus k. If I have these two, then I can say my vertex here will be at negative b over 2a, and when x is negative b over 2a, this will become y is 4ac minus b squared over 4a. Okay? Here, the vertex here is at hk. Okay? So, the value x equals negative b over 2a will give this 0. The only y that we have to take care now is this one here. Any other values of x will not make this 0. So there is a positive contribution. Okay? So this will be the least value when x is negative b over 2a and the parabola is opening upward. This will be the least value at x equals negative b over 2a when the parabola is opening up, but it will be the biggest value at x equals negative b over 2a when the parabola is opening down. Why? Because this one will become 0 at x equals negative b over 2a. And what happens to your y? It will just be this. Any other value of x, this will now have a contribution to the value of this y. We will be illustrating that. So this is the standard form of your equation now. So we can now say that in standard form, you can actually read out the vertex. Okay? For example here, if we have here y equals 2, x plus 3 squared plus 7, then this is in vertex form or standard form. Our vertex will be at negative 3 and y is at 7. And our function has a positive a, so it opens up. Therefore, this is the lowest point of your graph, and this is the lowest value of the function. Okay? So, let's try having exercises in this form here, and we want to reach this vertex form. The first one, y equals x squared plus 6x plus 4. So, there's no problem here because the coefficient of x squared is just 1. So, I'll just have this enclosed and I will just get the third term. So, what will be the third term here? The third term here will be what? Half of this is 3 squared that becomes 9. And then I will subtract that 9 and I'll have a 4. Regrouping this, I'm going to group the first 3 terms. And then the last 2 terms here, negative 9 plus 4. And writing this as a square of a binomial, I will get here x plus 3 squared minus 5. Therefore, my vertex here is located at negative 3 and negative 5. Okay? Let's have the second example. Y equals 3x squared plus 12x minus 5. Okay. For this example, I'll group the first two again. Here there's a 3. So I'll factor out 3. I'll get x squared plus 12 divided by 3 is 4x. Now, I'm going to complete here. What will make this a perfect square trinomial? It will be 1/2 of 4 is 2. Square that becomes a 4. I added 4, so I subtract 4. And I will have that. Again, as we have derived, we are interested in the first 3 terms here, written as 3 times x squared plus 4x plus 4 plus, don't forget to multiply 3 and the negative 4 there, so we have 3 times negative 4 and minus 5. Or I'll get here what? I can now express this as a square of a binomial. I'll now have x plus 2, and then this is negative 12 and negative 5 will give me negative 17. Therefore, my vertex here will be at negative 2 and negative 17. Okay. Let's have the third example. Y equals negative 2x squared plus 5x plus 3. Negative 2x squared plus 5x plus 3. Okay. Again, I will group the first 2 terms. Then I will factor out the negative 2. Negative 2 will now give me this divided by this will give me this. Now take note of this. Divided by this will give me negative 5 over 2x. Okay. And then I will complete the square. So what will be the third term there? 1/2 of negative 5 over 2. And then you square this will give me what? 5 over 4 will be 25 over 16. So this will be plus 25 over 16 minus 25 over 16. Whatever you do, you undo. So this becomes 0 and it did not change the value of this expression. Again, I'm going to group the first 3 terms here and I will be multiplying that with 2. Okay, plus 25 over 16. And distributive multiplication to this will give me what? Plus 2 times 25 over 16 plus 3. Okay. And writing that now as a square binomial, I will get x minus this one will be 5 over 4 squared. What about this one? I cancel this and this, I'll get an 8. So LCD will be an 8. This will be 25 plus 24. Or I will get here 2x minus 5 over 4 squared plus 49 over 8. And my vertex here will be at 5 over 4 and 49 over 8. Okay. The next example, so we have here 1/2 x squared minus 3x plus 1/2. Again, we will have that and factor out 1/2. So we will divide everything by 1/2. This divided by this will give me x squared. What about negative 3 divided by 1/2? This will be negative 3 times 2. Or this becomes what? Negative 6x. Okay, negative 6x. And what will be the third term here? That will be half of 6 is 3, square that is 9, minus 9. Okay. Now, I can now distribute this so that I will only have the first 3 terms here. And then, 1/2 times negative 9 plus 1/2. Expressing this as a square binomial, I get this. Okay, so this will be negative 9 over 2 plus 1 is negative 8 over 2, or that's a negative 4. This vertex will therefore be at 3 and negative 4. Okay, 1/2 is negative 9. That's negative 9 over 2 plus 1/2 is negative 8 over 2 or negative 4. Okay. And now, let's try to generalize what we have been having now. The four examples, I hope, are sufficient. Okay. So, our generalization here will be that this f of x, ax squared plus bx plus c, we were able to write this as a times x plus b over 2a squared plus 4ac minus b squared over 4a, which we were able to rewrite it as a times x minus h squared plus k, where our vertex here is at hk. Okay, notice that I could have written this as a function. Let's say g of x equals a x squared plus c, for example, where here I have a movement k units up, k units down, but there is an introduced constant here at h here. So what does this h tell us? It will tell us to move horizontally later on when we do the graph. This one is you move horizontally h units going to the right and k units up if k is positive, k units down if k is negative. Okay, so here we have here h is the horizontal shift of your graph, and then k is the vertical shift. So it would not be difficult to graph any quadratic function for as long as we are able to write the quadratic function in this standard form. And we can just read out this one. For example, here, the graph of this one will just be shifting the original graph 3 units to the right and then 4 units down. The graph of this can be derived from the graph of this by having h, the horizontal shift, and k, the vertical shift from the original graph g of x equals ax squared. See you in the next video.